Okay, so a teacher asks these 5 people in that order to multiply 2 single-digit numbers. Okay?
Yeah. Yes.
Okay, and so then these conditions are that every product is 50% more than the previous product, and that says a lot of things. Okay, so it's not roughly 50% more; it's exactly 50% more, right? So you have to be able to halve the numbers. Okay, and our question asks you what Dave got, right? So I'm going to explain this to middle primary people, and this is an example you came up with. So you have 8, 12, 18, 27, right? So 8 plus half of 8 is 12, 18, 27. The reason 27 doesn't work is now it's odd. You can't do 50% or more of that to get a whole number, right? Okay, but you could have also realized at this point, you could just times all these numbers by 2, okay?
Yeah. Yeah.
Right? If you times all these numbers by 2, then this would be, all it needs to be is even, right?
Yeah.
If you times it by 2, they'll all be even, right?
Yeah.
And so that would give you something that's even, and then you'd eventually get to your final answer. So also you did one for 32. So 32 is something which actually gives you whole numbers all the way up to 162. But you know that the answer has to be less than 81, less than or equal to 81, because you can't have more than 9 times 9, right?
Yeah.
Okay, so if you realize that, then you know the answer has to be less than 32, right? But for A has to be less than 32, yeah? And if A is less than 32, and it has to also be even, right? There's not that many choices. You can just try them all, okay? And so if you did that, you would get 16, right? Leads you to 54 and 81, yeah? So even if it doesn't work, knowing that it's 81, it's the biggest possible answer it could get. You have to have your A less than 16 if this doesn't work, right?
Yeah.
Okay, and there's not many numbers less than 16 which are even. Okay, to properly check that this is the answer and be sure 100%, you have to make sure you satisfy all the conditions, yeah?
Yeah.
So you actually have to also show that they're actually equal to the product of 2 single-digit numbers, okay? So for example, what times together will give you 16?
4 times 4.
So 4 times 4, yeah? And what times together is 24?
6 times 4.
4 times 6, yeah? See, this actually helps you. This proves that they're actually the product of 2 single-digit numbers, right? 36, what is 36?
6 times 6.
And what about 54?
6 times 9.
Okay, and then what about 81?
9 times
9 times 9, right? So this proves that they're 50%. So you know that they're 50% more, right? And it also proves that they're actually products, right? So in the actual test, this question will be worth 2 points, okay? So if you just got the answer 54, yeah, and it's correct, you get 2 points, yeah? If you got the answer wrong, but you came up with some good ideas like this, right? You get 1 point, right? Okay. So yeah, so as long as in this test, as long as the answer is right, you'll get the full points. But if the answer is wrong, you can only get all but 1 point based on what you wrote. Okay. Okay, let me give you a more advanced explanation of this. So every time you start with A, right? The number, what you do is you times it by 3 and then you divide by 2, right? That's what 1.5 is, right? It's 1 plus 50%. It's 150%, yeah? So you do this 3 times, yeah?
Yeah.
To get to D, yeah? And then you get 4 times to get to E, yeah? You see that?
Yeah.
Do you know how to multiply fractions? Okay, but basically you're timesing by 3 and you're dividing by 2, right?
So 3 times Three times.
Yeah, but the important thing here is not that you need to figure out what this number is. It's that for A to be for this is E, right?
Yeah.
Yeah. For E to be a whole number, right? See, if you keep halving it, things are not going to be whole numbers always, right? So for E to be a whole number, you have to be able to halve it 4 times, yeah? Does that make sense?
Yes.
So what's a number you can halve 4 times? What?
40. I mean 80.
No.
You can halve it to 40 and then to 20.
No, that's twice.
And then to 10.
That's 3 times. Wait, hold on. 80?
80 to 40 to 20 to 10.
80, so 40, 20, 10, 5.
40 to 20.
Wait, what did you start? You started 80, right?
Yeah. But then
80.
just minus the 40, then minus the 20, then minus the 10.
Hold on, so you said 80, right? So if A was 80, yeah, that would be 40, 20, 10, 5, yeah?
Yeah.
Okay. So I guess the reason that this works is because,
Oh, it's just divided by 2.
yeah, so something that can be divided by 2 4 times, right? Is, for example, something which has 4 2's timesing together, right?
Yeah.
So what's 4 2's times together?
Let me think. Wait, what does times mean again?
It's 16, yeah. Okay, so basically you need these 4 2's to be able to divide by those 4 2's. So the answer should be, the A should be a multiple of 16, right?
It is 16.
Yeah, so it's either 16, 32, or 48, right? But you see, if you do 16, it works, and 32 is too big, right? Okay. So that could be a quick way to get it, right? Another way to think about it, I guess, is that D is the answer you're looking for. You have to times it by 3 times, right?
Yeah.
So what's 3 times 3 times 3?
3 times 3 times. Let me try. 27.
27, yeah. So that means D has to be at least a multiple of 27, right? Because D has to be A times this and maybe divided by some
it is
stuff.
27.
Yeah.
3 times 3 times 3.
So it has to be a multiple of 27. The answer has to be a multiple of 27, right? So it'll be 27, 54, or 81, right? It can't be any bigger because 9 times 9 is the biggest, right? So there's only really 3 answers, yeah? So, and then we actually got that 27 didn't work because 27 was A equals 8, remember?
Yeah.
Okay, and 27 doesn't work because it's odd, right? Yeah. 54 is even, and 81 is odd, yeah? So 54 is the only even number that's multiple of 27, yeah? Okay, so lots of ways of thinking about this question. I think for most like year 10 students who are good and stuff, this would be just like a routine question. But for year 3 students, it's a very interesting question, right?
Yeah.
Yeah, so I think you can even do the
And
AIMO or
twos.
just do the year 2s. You can try and do the first question.